Hey everyone, this is question number 86 from chapter 6. Alright, so this question is about a skier sliding down a slope, then going off a ski jump, and then landing on a slope. So, first part of this question asks us to find the velocity of the skier at point B at the bottom of the jump, right? So to do that, we can just do conservation of energy equals EB. We aren't given an initial velocity, so we can assume that they're starting from rest. So at the top at EA, all we're going to have is potential energy, mgya equals, and then at the bottom, if we set this B is going to be equal to 0, just for this part though, so then there's no potential down there, it's just mgvb 1/2 mvb squared. All right, so rearrange that, and to solve for VB, and you get VB equals the square root of 2GYA. And then we can plug everything in. VB equals the square root 2 times 9.8 meters per second squared times, we're given both of these heights 45 meters, and then the jump height is 4.4 meters. So then just the slope height is going to be subtracting those two, and you get 40.6 meters. All right, and you plug all that into a calculator, and you get VB equals 28.2 meters per second. All right, so then part B asks us to find how far down the slope. The part B asks us to find how far down on the slope the person will go, okay? So I'm gonna just redraw. This is the jump, and then the slope goes down, and this is 30 degrees. And we have projectile motion here, so you should be thinking projectile motion equations, okay? So we can start this by defining the slope of the hill that she lands on, okay? So if we're looking at this just with trig and knowing how to define the slope of a line, we can say that the slope of this line is going to be minus x tan 30. Okay, so just tangent, opposite over adjacent, you know it's a negative slope, negative x tan 30. All right, so then we can go to our projectile motion equations, and one of our kinematic equations is x equals v naught t. So in this case, x is going to be equal to vb t. All right, and then we can also define y projectile equal to y naught minus 1/2 gt squared. And again, that's just a projectile motion equation, and we can substitute this definition into t. So we get y projectile equals y naught minus 1/2 g. We can rearrange this for t, so it's going to be x over vb squared. And then you can state that the skier lands at the intersection between the slope and the projectile motion. So we can actually set these two equal to each other. So you have minus x tan 30 equals y naught minus 1/2 g x over vb squared. All right, and you can get a quadratic formula from that. So rewriting everything just to make it easier, you get x 2, excuse me, you get gx squared, I didn't put my squareds term first, gx squared minus x 2vb squared tan 30 minus 2 2y naught vb squared equals 0. Okay, so now we have a quadratic equation for all of this, and we can write it out. Quadratic equation, x equals negative b plus or minus the square root of b squared minus 4ac over 2a. So in terms of what we have, that's going to be x equals, this was b was negative, so now it's going to be positive 2vb squared tan 30 plus or minus the square root of 2vb squared tan 30 squared plus 8g y naught vb squared all over 2g. All right, and that simplifies a little bit. The 2 goes away. And this one can cancel with the bottom one. Okay, and then we're going to have just solving this full equation, plugging all of our numbers in. I'm not going to write out all the numbers, but you can solve it just because it's a very long equation. This 2 is going to cancel as well. I'll write out the final though. X equals square root vb squared tan 30 plus or minus the square root vb squared tan 30 squared plus 2g y naught vb squared over g. Okay, so plugging in all of those numbers, VB, we just solved for that. Gravity you have. Y naught is going to be if we set the height directly below the slope, Y naught, it's just going to be 0, I believe. It's just going to be 0. So solving this, plugging it into a calculator, you get, very carefully plugging into a calculator, x equals minus 7.09 meters and 100.8 meters. All right, so that was the distance of the slope. The positive, this is a positive slope. Okay. That's the one that you're going to choose. The negative one doesn't really make sense. So the positive one is correct. And then in order to find the actual distance on the slope, we have to do S cosine. S is what we just solved for. So I'll say x cosine 30 equals S. And that's just because we have a slope. So this should be an S. This should be an X. I apologize. All right. So rearrange this equation and you solve for S, which is what we're looking for. S equals X over cosine 30. X equals 100.8 meters over cos 30. And you get S equals 116 meters.